Okay, so we are talking about the kinematic, means motion in the straight line. So when you see the word kinematic, so you have to know a few very important terms. So the first one is time. So time is used symbol T, and you must remember that time is always the domain. All the other function will write in terms of time. Okay, T is always greater than 0 because T is a scalar quantity. It will never be less than 0. Okay, so if they ask the question when, so if you have the question, okay, first of all, if you see the word initial, you know that you have to sub T equal to 0. Initial means starting. Okay, so that is one thing about time that you have to take notes of. If the word say initial displacement, initial velocity, initial acceleration, means you have the acceleration function, you sub the time equal to 0. That means starting situation. That is the meaning of the word initial. So if the question, if I have a questions, okay, with the word when, that means you are supposed to find time, T. So you look at the question. Okay, so this is the first variable that you have to know when you learn kinematic. Okay, second variable that you have to know is called displacement. Okay, displacement, usually, like for example, the example in question 1 given. Okay, you will give you ST equal to 2T cubed plus 3T squared minus 36T plus 18 cm. Okay, so this is displacement. So what do you mean by displacement? Displacement, that means is, okay, we are talking about position. Position of the object on the straight line. That means we assume the particle move along this straight line. So when we talk about motion in a straight line, so this is a displacement. So there is a origin. This is called the origin. Okay, so I give you the understanding first before I solve the whole case. Okay, so now when we study the motion of the particle, where is the particle? So with that one we call it initial position. Initial position. When I say initial position, I'm talking about S0. So I sub my T equal to 0. So 0 plus 0 minus 0 plus 18. So 18 cm. So when you have the displacement at 18, so that is how I interpret. Initially, the object is 18 cm to the right of the origin. So that means when the object is here, I start to study the motion of the object. So that is where I start studying the motion of the object. So I know when the object is here. So that is called displacement. So if the displacement is negative, that means the particle is at the right of the origin. To the right of the to the left of the origin. So that is talking about displacement. How far is the object from the origin? Are you okay? So your displacement is a vector quantity. If it's negative, means it's at the left of the origin. If it's positive, it is at the right of the origin. So it gives me the sense of the position. I don't know how far it moved. I don't know how it moved, but I know where is it. Position means where. And this is the reference point. Are you clear? So far, any question about displacement?
Miss,
Mm.
when it's, for example, if it's negative 18 and we explain it, do we say 18
Okay.
to the
So
left of the origin?
Let me give you an example. Let me give you an example. So I say, okay, when after 1 second, where is the object? Okay, so you see, when the moment I ask where, means I'm looking for ST. Am I right? So S after 1 second means T equal to 1. Are you okay? So S1. So it will be, let's count 2. So what you can do is, when you have your graphic calculator, class, straight away key this into Y1. You have your graphic calculator with you? Key into Y1. So it's 2 times 1 plus 3 times 1 minus 36 plus 18. Yeah, go faster. Okay, so if you use your graphic calculator, you straight away can get the answer. So can someone give me the answer?
Negative 13.
Negative
13. Negative
13. Okay, negative 13 cm. So where is the particle? Okay, after 1 second, the object is 13 cm to the left of the origin. Or we call it O, correct? So how we move, I don't know. How the particle move, I don't know. Okay, T equal to 0, it is here. Then how it move, I don't know. But I know after 1 second, the particle is here. This is after 1 second. How it move, I don't know. I just know the position of the particle. Where is it on it? On the straight line. How it move, I don't know. Where it go to, I don't know. Whether it move to the left or to the right, whether it stop, I don't know at all. So displacement only give you the sense of position. Where is the particle after certain time? Clear? Hello? Did I give you a good example? Okay, good. So remember, if the question asks for where, you look for displacement. If the question asks for when, that means you are looking for time. Okay? Can I not? Can I move to the third one? Hello? Yeah. Okay, so let me go to the third things that we have to study. So the another thing is the term is the velocity. So every one of us should know what is velocity. Is using V, okay, VT. So velocity is the rate of change of displacement. Okay, so if you know that velocity is the rate of displacement, means Vt is equal to S prime T. Agree? That is called rate of change of displacement. Yeah, so now can we get the S prime T from here? So we have 2 times 3, bring down the power, take away 1. Plus, bring down the power take away 1, take away 36. You differentiate 18, you got 0. So it will be cm per second. So this will be your velocity function. So look, this will be 60 squared plus 60 minus 36. So when we talk about velocity, the value of the velocity, so velocity is a vector quantity. So that means velocity, it can give us 2 information. It can give us the information of direction of motion. Okay, direction of motion. If velocity is greater than 0, that means the particle is moving to the right. Nothing to do with the origin, move to the right. Okay, if V velocity is less than 0, the particle is moving to the left. So now, if I want to find initial velocity, okay, what should I do? If I want to find initial velocity, what should I do? Okay. Andy, Siti Haja?
T equals to 0.
Yes, I put sub t equal to 0 into the velocity function. See that? Because the word initial. So I got 0 plus 0 minus 36. So I got negative 36 cm per second. So that means I interpret this as the object is moving to the left with the speed of 36 cm per second. So you see the negative sign tell you is to the left. So that means the object is here. If I draw a car, then it will be moving to the left like that. See or not? So now you understand. So velocity give you the direction of motion and the magnitude of the velocity give you the speed. Are you okay? Okay. So now we have the velocity. So what do you mean by if I say the object stop moving? So if I change the question from here, I move to the question like, when is the object stop moving? So when I'm looking for time, am I right? What do you mean by stop moving? Can someone give me? What do you mean by stop moving?
It stays still. Oh,
Stay
sorry.
Velocity
still,
equal to
so
0.
what? Yes, yes.
Oh,
Velocity
Someone
equal to
can-
0.
Yes. So you just say stop moving, stay still, is still another word. You don't put it in a mathematical form. So when I say stop moving, that means velocity. This is your interpretation. You see, a lot of times when we fail to answer a math question is because they put it in English. We are not able to put it in math. So you have to remember, stop moving means what?
velocity equals to 0. Got it.
So bear that in mind. So if I say velocity is equal to 0, just now the velocity is 6t squared plus 60 minus 36, correct? So I put it equal to 0. So you can use your scientific calculator and straight away get the answer. It's a quadratic. So can someone tell me what is the answer? Yeah. So we have to bear in mind, t is greater than 0. Therefore, t equal to 2. So I got that answer already. Okay, now. Okay, so look, if I ask the question, where is the object changing its direction of motion? Okay. So I want to know where. So what does that mean? If I want to know where, I want to look for what? You are looking for displacement. Correct? So displacement is ST. So you're looking for displacement. So first you think like that. So if you want to look for displacement, when the object changing its direction of motion, so you must have the, if I analyze like that, you must have the, you have to find the time when the object changing its direction of motion. Correct? You have to find. So now, before you can find when, you have to know. So this is a lot of analysis. Huh? What do you mean by changing its direction of motion? You have to know the meaning of this. What do you mean by changing the direction of motion? What do you know? If something want to change its direction of motion, something have to happen. What is that something? Like just how we know. The sign must change. Correct? So look, just now we have the motion in the straight line. Correct? This is the origin. At the beginning, the particle is here. It is moving to the right, to the left. Correct? We know. So it moves from here. Move. Okay. So if you want to change the direction of motion, you have to stop first, am I right? The particle have to stop. Then only can change the direction of motion, am I right? Every time when you make a U-turn for the car, you didn't realize only because the changes is very fast. You have to stop first. This one we call it momentary arrest. So this one we call it instantaneous rest. Instantaneous rest or momentary arrest. So that means if you want to know, you have to find the time when the object changes its direction of motion. So you have to remember this fact. Must stop. Then only can change direction of motion. But you have to remember, I can stop, I can don't change direction of motion, correct? So now what do we need to do? So that means if you want to answer this question, you have to draw the sign diagram of what? So to solve this problem, you must have the sign diagram of what? You want to talk about stop. Can someone give me some suggestions? Sign diagram of what?
Velocity.
Yes, you are right. Sign diagram of velocity. Because we want to know when the velocity equal to 0. So I draw the sign diagram of velocity. So every time when you talk about motion in the straight line, you have to be very careful. Okay. Time always start from 0 onward. So from this part, we get the t equal to 2, correct? Hello? So from 0 to 2 seconds, the particle is moving to the left. You can use your graphic calculator to get you the sign. And this one moving to the right. So here, V2 equal to 0. So then from this sign diagram, I can interpret like that. T from 0 to 2. The object is moving to the left. Okay, then after that, t greater than 2, the object, it never turn anymore. Object is moving to the right. So that is how I interpret. So in order to answer this question, where is the object changing its direction or motion? First of all, I have to know the true fact. It must stop, then only it can change the direction. But it doesn't mean that stop must change direction of motion. Okay, so I get Vt equal to 0 first. I get the time. So after I get the time, then only I answer this question. So to give the answer for all these are explanation. So to answer this question, I have to find the time. Then after that, I put S2. That is equal to, so you can use your graphic calculator. I told you already, everyone, have you key in your ST into the graphic calculator? Into Y1? Yes. Only Glady answer me. The rest? Okay, Kevin, give me what is S2. Straight away, calculator. Huh? You got 0. S2 is 0. Sure. The rest? Is it 0? Okay, so I trust you. S2 equal to 0. Okay. So that means my diagram is wrong. Huh? Ah, someone got negative 26. Oh, Kaban. Do you know which one you have to key into your graphic calculator? Not here, this one. I'm not talking about velocity.
Yeah, I key in this one.
You key in this one, so you call out Y1 or you call out Y2?
Oh, okay. 0, 0.
Oh. So your Y1 class, your Y1 is ST. Your Y2, you just put D, dx, Y1, X equal to X. This is your VT. You better write it down, and your Y3, afterward, we will do that again. Okay, so can I go to that? Okay, so what is the answer? Negative 26, is it? Kavan, do you get negative 26? Brandon?
Yeah, go.
Sure. Not 36.
Wait, I think I keyed wrong already. Yeah.
You see that?
I got negative 26, teacher.
Yeah. You see? All of you, where are you? I keep saying key in. What are you doing? Negative 26 cm. So here is negative 26. So that means from here to here it moves. Correct? So the total distance travel will be 18 plus 26. Correct? So all together. Yep. So I will go to that later. So do you know how to interpret now? Okay, so that is another important thing. Okay, so I have explained what do you mean by velocity, how to interpret the question. Afterward, we will answer the whole question. Okay, the next one is the acceleration. Acceleration is the rate of change of velocity. That's it. Okay, the fourth one, acceleration. So acceleration, we use A, is the rate of change of velocity. So that means acceleration is V prime T, or is called S double prime T. Am I right? So in our case, it will be 12T plus, because 12T plus 6, correct? Okay, so if you look at here, T is always greater than 0. So 12T always greater than 0. So 12T plus 6 is always greater than 0. So the acceleration is always positive. So that means the velocity is always increasing. Correct? The velocity is always increasing. Yeah. So this is talking about acceleration. Okay, so the three things, are you okay with that? So if the question asks for when, you are looking for time. If the question asks for where, you are looking for displacement. If the question asking for how fast it moves, you are looking for velocity. If the question asks for direction or motion, you are looking for velocity. Okay, the rest of it, we will go through the question and I will explain more. Can we? Okay, now I want you to spend some time to do part 1 of question 1. So everyone, you should have this in your graphic calculator already as your Y1. Okay, so they say part 1, find the velocity and acceleration function for the object and draw a sign diagram for VT and AT. So what we do, VT, this is S prime T, then you start to write down, okay? Please do it by yourself. I've done it already just now. And please make sure you write down the unit of measurement, okay? Okay, so if you want to draw the sign diagram for VT, first of all, you have to put VT equal to 0 first to find the 0. So from scientific calculator, we got our T is greater than 0. So T must be equal to 2. So you draw the VT sign diagram. You put the 2 here. You use your graphic calculator Y2 to determine the sign by yourself. So you got here negative, you got here positive. So that is the first part. Okay, now they ask for AT. So you differentiate this again, 12T plus 6. This is centimeter per second per second. Okay, so AT, everyone we put AT equal to 0. So 12T plus 6 equal to 0. So T is greater than 0, so no solution. All right, so therefore my AT sign diagram will go in this way. Always positive. You can use your scientific graphic calculator whereby your Y3, right? Okay, done with part 1. Okay, part 2. Initial position. So what should I do if I want initial position? How Xuan? Sleeping. Initial
sleep.
position. Now I got 3 functions. You tell me, what should I do with these 3 functions? 1, the one in black, the one in red, and the one in green. So which one should I use to do number 2? How Xuan?
Green one.
Green one, green one is acceleration or how Xuan? Just some Mr. said position is which one?
Black one.
So black one. Okay, so what should I do with the T?
Sub in the
What
2.
should the value of T be?
2.
Why 2? How Xuan? Just now I asked you to remember initial means what? Johan?
Yeah, sub T
Yes.
0.
You must make me angry, then only you want to answer correctly, is it? Initial means T equal to 0. Hey, I'm old already there.
Yeah, I know.
Yeah, law. I don't want, I want to be young, okay? So don't make me angry. So you have to sub T equal to 0, understand or not? All this you have to remember, if not, how to do?
Yeah.
So it's 18 cm. So this question didn't ask you to interpret, and just now Miss Do interpret for you, correct? So that is the initial position. So usually after you do it, it's better to interpret the object. Initially, the object is 18 cm. Okay, someone continue. Esther?
Yes, Miss.
Yeah, initially the object is 18 cm.
Yeah.
What? Continue. To of the origin. Esther?
Right.
Hello, young people. You are still off record first. Okay, let's go to part 3. Say, find the initial velocity of the object, the velocity of the object when t equal to 4. So, part 3, part 1, part A. Okay, what should I do with part 3, part A? Hafiz,
Yes, miss.
what should I do with part 3A?
3A
Initial
is
velocity.
V0. V to 0. T equal
No.
to 0.
Yeah, you have to put t equal to 0 into the rate function, correct? The velocity function. So part A, I'm looking for V0. Yeah, just now we have done that. You can just straight away write negative 36 cm per second. Nothing wrong. Do you get me? You don't have to show me your substitution. Mark will not be given. Okay, so how do we interpret that? Okay, how do we interpret that, Gladys?
Initially, the object is moving to the left at the magnitude of 36 cm per second.
Yes, you are right. So instead of at the magnitude, what you can do is you say initially the object is moving to the left with the speed. So that is the difference between speed and velocity. With the speed of 36 cm per second. Speed is without direction. It's the magnitude of the velocity that is called the speed. Can or not? Okay, how about part B? How about part B? No, Shazana. How about part B?
Sub the t at Vt equals to
4. Sub with the value of 4. Okay, can someone use your GC and give me the answer? Okay, Shazana, can you give me the answer?
84.
84. If you don't mind, can you interpret also? After 4 seconds.
After 4 seconds,
the
object is moving to the right with a speed of 84 cms negative 1.
Good. Okay. Can I not? Okay, part 4. Find the time and the position when the object reverse direction. So you see the word reverse direction. Okay, so this is the keyword. So you want to solve max, correct? You always start from the information given at the back of the question. Okay, reverse direction means what? Okay, what should I do first? TDS. TDS.
Yeah. You need to find the time first.
You have to find the time first. So reverse direction means what? You must
Change direction.
change direction. You must stop.
Yeah.
So from part A, from part 1. So this one you don't have to do because it's continuous. From part 1, Vt equal to 0 when t equal to
2.
2. Correct? So the question asks, find the time and the position. So time done. Position means what? S, displacement. S2. This is called position. Okay, so what is S2? That is?
Negative 26 cm.
Negative 26 cm. Yeah. So that means, where is the object? Yeah. The object reverses its direction of motion when it is 26 cm to the left of the origin. So that is how you interpret. Yeah. Okay, so done with that. So now let's go to part 5. Find the time when the object speed is increasing. Okay, so this is something that you have to bear in mind, better remember. Okay, this is something that you have to remember. When you want to know whether the speed is increasing or decreasing, you must have both velocity and acceleration sign diagram. Okay, so same sign, increasing speed. Opposite sign, decreasing speed. So this is the true fact that you have to know. Okay, you go and imagine why is it like that first by yourself. Okay, so now I have the velocity. So I will draw these two on top of each other. In this case, our AT never becomes 0, it's always positive. So the question 1, what? Show that the velocity is always increasing. Huh? No. Find the time when the object speed is increasing. So must be same sign. Same sign is this region, correct? Hello? So therefore, t greater than 2. Are you okay? So remember, for speed, you have to refer to both acceleration and velocity sign diagram. Done? Okay, let's go to part 6. Show that the velocity is always increasing. So how to show that velocity is always increasing? Rate of change of velocity is acceleration, correct? So look, acceleration is 12t plus 6. Okay, so I want to show. So what I do is I start with t greater than or equal to 0. So therefore, 12t plus 6 is greater than or equal to, okay, if you want, you can go step by step. If t greater than 0, 12t will be greater than or equal to 0, correct? Something greater than 0, you plus 6, that is your AT, will be greater than or equal to 0, correct? So this one you show, therefore, velocity is always increasing because acceleration is always positive. So I have to show this. I cannot just write this statement. I cannot draw the sign diagram. Are you clear? You have to analyze the acceleration function. Are you okay? So that is number 6. Okay, number 7 should be quite easy. Okay, can someone tell me what is the answer for number 7? Find the acceleration when t equal to 6. So this is no problem, am I right? So which one must I sub in? Which one must I sub in?
Green color.
Green color. Ah, this time you are alert. Green color. Okay. A. So I have to sub in with 6. So you use your calculator, Y3. So can you give me the answer? The one asked me to sub in the green color.
78.
78 cm per second per second. Okay, now I'm going to explain part 8. This is very important. So I go to the next page. Okay, part 8. Okay, find the total distance traveled by the object in the first 3 seconds. Okay, first I want to talk about what do you mean by first 3 seconds. Okay, in maths, if I say first 3 seconds, that means my time is start from 0 to 3. Clear? So, when you talk about, you want to find the total distance traveled, first of all, we use this method called, we want to produce motion diagram. What do you mean by motion diagram? Motion diagram means you want to talk about the motion of the particle on this straight line. Start from this time. Okay, so there are 3 very important positions. So every time when you have this, you have to ask yourself, does the particle stop? Or I say reverse. Its direction of motion during this period of time. I have to ask this question. Yes or no? Yes or no, class? The answer is yes, am I right? We have done it. So there are 3 important positions that you must find. So first position, initial position. That is S0. Okay, we know that is 18 cm, right? Second position is the, if there is does stop, so stopping position. So that is S2, which is negative 26 cm. Number 3, ending position. That is S3. Can someone give me the answer? Using your scientific calculator, a graphic calculator, quick. -9. Okay, so now this is my origin. Here is 18. The particle move from here right up to here. Here is -26. Yep. Then after that it turn. Then come here. Here is -9. Correct? Hello? So the total distance travel will be 18, 26, 26 minus 9. Can Anna? So you have the motion in the straight line, you can find the total distance travel easily. And that is how we produce our motion in the straight line as well. Motion diagram. Because sometimes the question will ask you to draw the motion diagram for this period of time and hence find the total distance travel. So therefore, the total distance travel will be 18 plus 26 plus 26 minus 9. Then you get the answer. Are you okay? So you don't have to put absolute value or whatsoever. Just look at the diagram, then you will know. So this is a much easier way. So every time before you draw a motion diagram, this is a very important question that you must ask. This is very important. This one. Important question that you must ask. If during that period of time, it doesn't change its direction of motion, then we are safe. You can just find 1 and 3 good enough. So kinematic is a matter of your understanding only. Right? So if they want you to draw the graph, then you just use your graphic calculator to draw the graph and interpret. So you try the other one. Tomorrow I will discuss the other question with you. Can or not? Hello, student? So I hope this gives you. So kinematic is a very simple one. It's just that all the 4 factors just now I told you. This one, this one very important. Okay, all this you must memorize. What do I want? Okay, then after that you just read the question, then you will know what to do. And in your SAT2, sure got one question like that, almost similar to this. Yep, it's just that the function I give you is different only. And all can be done by using your graphic calculator. Okay, thank you, class.
You miss.
Mm.
Thank you, sir.
Thank you, miss.
Thank you, Miss.
Yes.